Hello everyone. So I am Vicky Kumar Sharma, Maths 1 instructor. So today, like it can be, you can ask me questions and I can answer you, and also like I can take up certain questions, which is quiz oriented. So that is how our session will go for today. So like, if you have any doubt, you can ask me. Like I can take up 1 or 2 questions per time.
Sir, one doubt I have, it is
Yeah.
in the practice assignment,
Okay.
if you go to question number 8,
Which week?
practice assignment
Of which week,
7,
please?
this
7.
is
Could you quickly do that? Or I'll just take up the question, few of the questions. Maybe
no,
like I myself can, yeah.
I have the question, sir, with me.
Could you tell
It
me
is
which week it is, so that even I can answer?
it is week 8, sir, week 8.
Okay, week 8.
Week 8,
Practice assignment, is it?
practice assignment, go to question number 9.
Question number 9, is it?
Yeah.
Yeah, please tell me.
Yeah, in the question number 9, there is a fx, g of y and h of x is given.
Correct.
And h of x is equal to composite function f of g of x. Okay.
Correct.
Now, the equation is given. Now, if you come to the question number 11, where they ask the domain of h of x.
Okay.
And this question I solved, sir, actually. Find
Okay.
the domain, but my answer is not matching. And I also go through the video solution, but the way they have solved this, I am not convinced. I have some doubt.
Okay. So
See, sir,
what exactly?
what exactly my doubt? Let me take clear that the
I'll write
function.
down the question so that even others will have the access to it.
Yes, sure.
Yeah. So just give me a minute. So we have function f of x equals to. Is my screen visible to everyone?
Yes, it is visible, sir.
Yes, sir. It's visible, sir. Yeah.
Yeah. And g of y is equals to root over of y square minus 9.
Sir, f of x equal to fx 5x plus 9 by 2x.
Okay, sorry. Yeah, 2x, and g of y is root over of y square minus 9. And
Correct.
h of x is
F of g of x.
G of x. Okay.
Okay. Sir.
And question number 11. We are given with the domain, right?
Yes. So
Okay.
I find the domain, but my answer is not matching, and the solution they are given, I have some doubt on that, sir.
Okay, can you tell me where you are stuck, like in which part of the solution you're stuck?
Yes.
Yeah.
Sir, first to find the h of x domain, I first find the h of x function, which is
Correct.
5 into root over y square minus 9 plus 9 by 2 into root over y square minus 9.
Okay.
So this is my h of x. Now,
Correct.
this composite function, first I find the domain of g of x. In this domain function g of x I have found, I find the domain there, g of x function.
1 minute. What's your good name?
Yeah.
Samit, is
Shomit.
it?
Yeah.
Shomit. Okay, Shomit. So 1 minute. So you would have obtained this h of x is equals to, I will write down this part. 2.5 plus 4.5 upon root over of x square minus 9, correct?
I didn't do that simplification. I simply write that 5 into root over x square minus 9 plus 9 by 2 into root over x square minus 9. I didn't simplify that. It's
Okay,
anyway.
you just simply wrote that. Okay.
Yeah. Simply put the g of x value on the f of x.
So you mean to say like h of x is equals to 5 root over of x square
X
minus 9
plus 9
plus 9 divided by
2 into root over x square minus 9.
okay.
Okay.
Yeah.
Okay. Now, if you look at the g of x, then g of x can't take any value y square minus 9 is less than 0.
Yeah, right.
Right. So, I find the first domain and range of g of x.
Okay.
So, range of g of x is 0 to infinity because it is a square root function.
Why 0 to infinity?
Sorry? Because it is y square minus 9, na, square root. So, range of g
Okay.
of, yeah, it is 0 to infinity.
Okay.
Now, I try to see this 0 to infinity all the value, whether this f of g of x will take or not. Whether
Okay.
the range of g of x is valid for f of g of x or not. So I find now there is a problem.
Okay.
Because at 3, because 0 to infinity also have the value of 3. So 3 as a value in f of g of x can't take. Then the function is h of x is not valid.
Okay.
So I have to find the input, the domain of the g of x where the output is 3. So I simply put 3 is equal to root over y square minus x square minus 9 and find out the x.
Okay.
So these are the x value for which g of x is giving a value 3, which is in turn creates a problem in f of g of x.
Okay.
So I removed that input value from g of x, and
Okay.
now the balance, my balance domain of g of x or modified domain of g of x, it's simply valid to h of x, which is the range of h of x.
Okay.
So if I try to solve this problem in this way, I found the x value is 3 under root 2 instead of 3. But they are simply taking the value 3 and then say that this function is not valid. That is true. But when it is not in a composite function, but when the function is in composite, can we do like that? The solution that they have given. This is my confusion.
Okay. So basically, like the other way which you are taking through. So see, Sumit. So
Yeah.
basically, here the solution what is given is again there is no doubt it's not wrong. Why? Because
No, I am not
see,
saying wrong. I am
yeah.
saying ki h of x is, if you can just means thinking in this way, I have find the h of x in this function, then whatever you are saying and the solution is providing, it's correct, no issue. Because at
Okay.
x equal to 3, you can't, this function is not valid. But if we look the h of x function, it is a composite function of f of g of x. So range of g of x become the domain of f of x, h of x, if all the range value is satisfied in that domain. This is
Okay.
the idea of this composite function. So I have taken gone in that way. So whether if you come in right way or left way, you have to answer in a common answer. No, I am not arriving on that. Where I am doing the mistake.
So you are taking range of g of x, correct?
Yes.
So range of g of x is what? Can you
0 to
tell me what is
infinity.
range of g of x here?
range of g of x is equal to 0 to infinity.
Correct.
Yeah.
Okay. So now, yeah. So now you are telling what is given over here in this part, how to take the other part of it, right? Like since this is defined, this is giving only for positive value, but what about the negative parts?
No,
Isn't
negative.
it?
See, so g. No, no, I'm not taking out the negative because g of x can only generate the positive part, 0 to infinity. It
Okay.
can't be negative, na?
Okay.
So this 0 to infinity as a input is going to the domain in h of x.
Okay.
Now I am trying to see within 0 to infinity what are the value which creates problem for f of g of x.
Okay.
And I
So,
find
hmm,
3 as a point where this h of x is having a problem.
hmm,
Now I try to look back where this 3 is coming. 3 is coming as a output of g of x. So I try to find what are the value that I am giving to the input of g of x. So it produced that 3. So I go there and eliminate that all the input from g of x.
hmm.
This is the way I am solving this problem when it is not matching, sir.
Yeah. Who is this?
I'm Srinath.
Yeah. Hi, Srinath. You have something
Hi.
to say?
Yeah, in this case,
Yeah.
actually the problem here is that he's thinking the range of g of x is the domain of f of x,
Domain of the next function. Yeah.
but that is where the problem arises, because
Right.
if we have to, if for this function to be valid, the only values of x which this cannot take are minus 2 to 2, assuming it is
Correct.
integers. Correct. So it
Yeah.
is all values from minus infinity to minus 3, and all values from 3 to infinity will be valid.
Correct.
Therefore, the m is 3. You can straight away look at this h of x and say that uh, the domain is minus infinity to minus 3 and 3 to infinity, and anything
Hmm.
in between is not part of it. So
Yeah.
that is how we have to solve it. But it is not the other way, like the range of g of
Yeah.
x is going to be the domain of f of x. That is not right.
Sumit, is it fine?
That is
No, no,
for, I
no.
think, some log
No, no,
functions.
no. It's
Yes.
create more problem. Simple function, what you are telling, sir, I am absolutely with you. But it is a composite function. We are writing f of g of x. That means if you simply see the f of x function, what we are seeing in the domain, what are the problematic x in the function. So here x is g of x. So I will always see the bound of g of x. I cannot take infinity, minus infinity to plus infinity for g of x, because g of x as a function
Correct.
never
Correct.
produce that.
See,
Sumit,
look at the f of x function. It is 5x plus 9 by 2x. In
But
this
here it is
case,
the g of
uh,
x.
no.
Listen.
In this f of x, say assume x can take any value. But when it becomes the composite function where this f of x takes g of x, it can take all values except minus 2 to positive 2.
Minus 2 to positive 2.
And that, because that will give the square root, it will become negative.
No, 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 no. That is
Sumit,
the domain for the g of x. But we have to see the range of g of x, which is the input value for f of g of x.
hello, Sumit.
Sir,
Yeah. So basically, as you are telling, like you are taking the range of the function and it's complicating the things, right? But
Correct.
you have to understand here, the range of g of x is something here. It's in the h of x, and now h of x is the new function, right? So if you even if you take the range of it and substitute, because this part is g of x, right? Correct?
sir,
And this part is g of x. Sumit?
Yeah, please. Yeah, tell me, sir. I'm listening.
So the thing which I have marked here, can you see that those are the g of x, right?
Yes.
Right? And you can see h of x is no more just dependent. I mean, it is though dependent on g of x, and as you are telling, the range of g of x is from from 0 to infinity, right?
Yes.
Yes. So, but that range in terms is dependent on the x, right? So if you give those x values, you will get some different values because here you have 5, 9, and 2. These factors will definitely play a role there, isn't it?
But sir, still I am not convinced. If you can, will you please draw 3 box in a simple one line? Just 3 box with a gap.
Three box with a gap.
3 rectangular box if you can draw
Okay.
with a gap. Then beside that, yeah.
Okay, Sumit.
Yes. Then in the first box, if you write g of x,
Okay.
in the next box, you write h of x.
Okay.
Then before g of x, you arrow a value where the input is coming, which is x.
Okay. So what do you want me to give here? X values.
Yes, in left hand side of g of x, the x value is coming.
Okay.
The second box cannot be h of x, right? The second box should be f of x.
Yeah.
That means f of g of x. That is h of x.
No, the
X
two
value is
boxes put
coming to
together. The two boxes put
no.
together is f of x.
Hello.
Yeah. Who's
May I
this?
tell something? Like,
Yeah,
Sumit,
please.
I think your doubt is that you're saying that 3 is a problem, correct?
Sorry?
So when you're saying that 3 is giving you the problem in the function, correct?
Yeah.
So when 3 is giving a problem in the function, you cannot equate that to g of y. That is what's inside g of y. G of y will give a problem and g of y is 0 in
No.
in h of x.
What I am telling, this 3 as a input from where we are getting? We are getting the output from the g of x, na?
Yeah, output of g of x, when it's 0, then it's an issue. When g of x is 3, there's no issue.
Mm.
When g of x is equal to 0, then function do not have any issue because square
Yeah,
root can take 0.
no, but it's in denominator, no? By 2x, where x will become g of x that time.
Yeah.
That is where you're going wrong.
No. Correct. What you are telling, because here denominator having two terms. One is itself the entire square root of x square minus 9 can't be 0. And also inside the x square minus 9, which has to be greater than equal to 0.
Correct.
Right? So if we put together these two, this stands the x square minus 9 has to be greater than 0.
Hmm.
Right?
So x should be greater than equal to 3 or lesser than minus infinity to minus 3. That's
But
it.
this x square minus 9 under square root, this is a function of g of x. You cannot
Correct.
take it simply in this
Yeah.
way. You
No,
have
correct.
to
So when you're taking it
because
in
when
g of x, so it should
no
not be equal to 0 in f of x. That's it. G of x should not be 0 because that's in denominator.
what I am trying to say,
Hello.
when we are giving the value
Yeah,
x
hello.
as an input, it cannot go to the h
Good
of
afternoon.
x. First
Good
it
afternoon,
will
sir.
go to the g of x, then
If I can
it
give
will
a little
come.
explanation for this, maybe.
Yeah, who's this?
Yeah, Afnan here. If I can,
Yeah.
I want to give some insights on this. So please, if I can.
Okay. Yeah. So
Please.
yeah, you can give now. Yeah. And we'll take another 5 more minutes for discussion on this question, and then we can move on to the next part of it. And Sumit, yeah, so please go ahead.
Yeah. Hello. So I think the problem here is that when we are taking g of x,
Mm-hmm.
g of x is an independent function, okay? And
Okay.
f of x is a different function, okay? Now what we
Right.
do, g of x has a range, which is perfectly fine. we have a range from 0 to infinity, and that is great. Now, f of x is an independent function which also have some domain. Okay. Now, only by taking g of x inside the argument for f does not necessarily mean that we are taking the entire range of g of x as f as the argument for f. So even though g of x can generate values from 0 to infinity, when we are taking it as argument for f of x, we are not taking the entire range.
Yeah.
Correct. That's
And
what I am trying to say.
yeah, and that's why that's why we should not relate the range of g of x as for the domain of f of x, because those are independent functions.
No,
This
no,
is what
no.
at least I believe.
No, how come it is independent? I will never get a value inside the input in h of x unless g of x produce something. Because it is
Sumit,
the
you are
output of g
saying
of x
g
is the
of
input to h of x.
no, you are saying g of x cannot be 3, correct?
Yes, g of x cannot be 3 as per this
You put
condition.
you okay in
Sir,
f of x, in h of x, which is a function of f of g of x, you put 3, it will satisfy, because you'll just get 5 into 3 plus 9 by 2 into 3.
No,
That's
no, 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 no.
that is what is f of g of x, right?
No, 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 no.
G of x
F of g
cannot be
of
3,
x,
you're saying. So you put 3 in f of x.
f of
It will
x is no
satisfy.
x is g of, they are f of g of x. That is only f of x. I
Yes,
am
f
talking
of
about
g of
h of
x,
x
where you're
composite.
saying g of x cannot be 3. Correct.
Yes.
So if g of x cannot be 3, in f of g of x, if I put g of x is equal to 3, that's f of 3.
Huh? Sorry?
If g of x cannot be equal to 3, I'll assume g of x can be equal to 3, okay? So if it is equal to 3, then that's f of 3, which is not an ambiguity.
No, no, g of
That's
3 you have to put. G of
not
3
g
is
of,
equal
yeah,
to,
g of 3 is not allowed, but g of x can be 3. So when you're equating that to 3 x square minus 9, that's where you're wrong.
no, why I am wrong? That is the thing I don't understand.
G of
sir,
3 is not allowed, but g of x can be 3.
sir,
Yeah, please.
sir, can you write f of x there somewhere? Just f
Yeah.
of x.
F
And
of x
against
function, right?
that, with, no, don't write the function. I just want to
Okay.
just write the domain as open within open interval minus infinity to positive infinity,
Okay.
and g of x closed interval 3 to minus 3 to positive 3. This is not allowed. In g of x, all of f of x is allowed except this particular interval. Okay, so h of x will be minus infinity to open brackets, I mean open interval minus infinity to minus 3 union 3 to positive infinity. That is the funda, because there in the question itself the m is in open interval, therefore 3 is not included in that thing. If you just check the question, that is why the confusion is happening, I believe.
Yeah, Sumit, is it fine now?
Except
Still
this.
some confusion.
No,
Anyway,
sir.
because you
Now,
are,
if you just write h of x, h of x equal to with open interval minus infinity to minus 3 union.
sir, just if
Both
you
are
just,
union 3 to this. Now, this 3 is what is asked in the question, because it is an open interval. It doesn't mean it is equal to 3. It is above 3. It is not included in the range. Instead of 3, it is written as m in the question. That's all.
sir, if you can
Yeah,
just
Sumit.
If you put
explain just
3,
one thing.
if you put 3, what will happen is the denominator will become 0 and the function will become invalid. Actually, you cannot put 3, but the value of m is 3 because it is not included in the range, in the interval. You just check
Right.
the questions, or if you can project the
Am
question
I
on
audible,
the
sir?
Yeah.
yes.
Yes, sir. I just wanted to say that domain of Hx will be the domain of Gx intersection range of Gx.
Yeah.
No.
No,
Why?
how?
A domain of Hx will be all the domain of f of x minus what is not allowed in g of x.
Correct.
Yes. So that means the
That
domain of
means
Hx will be minus infinity to infinity,
no.
excluding 3 to minus 3. Okay.
X correct.
Yes.
So that
To
exclusion
extent,
of
if you show
minus 3 to
decimus.
positive 3 is given in the question in open brackets. That is why 3 is the answer. But
Yes.
it doesn't mean 3 is a valid input for g of x. If you just, sir, if you can show the question or put a screenshot of the question, you will see that the m is in open interval.
Yeah, actually.
Sir, you just
In the question, it is given as open interval only.
Correct. The closed interval comes only in case of g of x, where
Right,
x strictly minus 3 to plus 3 is not allowed. So actually, he
Sumit,
thinks
Sir,
3 is not the answer, but above 3 is allowed.
yeah.
so can we see this hx as a function where the denominator cannot take the value 0? That is, under root x square minus 9 cannot be 0.
Correct.
So if that is the case, then g of 3, when we equate, it is equal to 0. So that
And the
is
g of
where
3 is not allowed because 3 is
not
given
allowed.
in
That
the
is what
open
I said.
interval.
Yeah,
Correct.
that's what I said. If you put g of 3, it is equal to 0, which will not
Correct.
be fed into h of x.
Correct.
So the x is equal to 3 is not included.
Correct. 3 is not included, but since it is in open interval, m equal to 3 is the answer for that question. That's all.
Okay.
Sumit, if you still have a doubt, can you please put that in the discussion forum so that even other can.
okay. No problem. I will write it in the discussion forum. No issue.
Yeah, Sumit.
Sir, I have the next
Just
doubt.
one clarification. Just one clarification. After that,
Yeah, Sumit.
you can take it. Just tell me whether I am making mistake here or not. When we take the range of gx, means output of gx, then all this output, all this output, I will check in the f of x as a original function or f of x as a composite function.
Conceptually, you are thinking that the output of g of x is the domain for f of x, but ideally the domain of f of x is all x, but excluding those x that are not allowed for g. That's all. It is not that g is output. You don't have to think that way.
Yeah, I'm with Srinath. So Sumit, is it fine now?
Okay, sir, I will write it in discussion forum, sir. No issue.
So, sir, question in graded assignment 7, question 5.
Sorry, graded assignment?
7, question 5.
Okay. Yeah.
So when we find the next question where we have to find the maximum degree of the gx, maximum degree of the remainder, where the answer is given as yeah.
So tell me what is the problem here?
So in the PDF solution, it was written that f and h have the same degree.
Okay,
and
so
gx has a
even
value.
for, I'll take up this question. So even for others, I'll put this question. This question is kind of important in terms of your quiz point of view as well. So we can spend some time on this question. So
which
here
is the
in
question?
Graded assignment 7, question number 5. So basically here we have been given with degree of f of x. right?
Okay, yeah.
You asked me this question. What's your good name?
Priyanshu.
Yeah, Priyanshu. So this is something given to us, right?
Yeah.
This data was given and degree
Sir,
of
I think you're saying the question number wrong. Graded assignment 7, question number 5 is not this.
oh, is it? Okay. Let me
No,
look
sir,
at
it is this only. For this only.
this.
I'm looking at the consumption of new plastics in year X. That is what is showing
So I
here.
guess question number
Graded
7.
assignment 7.
Graded assignment.
Number 6,
Question
what
number
you are
7.
discussing, sir. Question number 8, sir.
Question number 8, okay.
Okay, so am I discussing the right thing?
Correct. What will be the maximum possible degree of the remainder of f of x plus g of x is divided by h of x?
Yes, sir, that question only.
Correct, correct.
Priyanshu, am I doing the right question?
Yes.
Yes, sir, you're doing the right question. So continue.
Oh, okay, fine. So yeah, so the degree of h of f of x is equals to degree of h of x,
Yeah.
and that is
Equal to
also
5.
given as 5 here, and it is told that h of x divides f of x, correct? So in this thing, when h of x divides f of x, what will be the remainder here?
Constant, because it would become divided.
Yeah, when it divides,
See,
it
because
becomes
both have the same degree.
no, the remainder will be 0 here, because it says it divides, means it's, when I say 10 divides
Yeah.
5, I mean 5 divides 10, so it means what?
Yeah, got
What will
it.
be the remainder? It will be
Yeah.
0, right?
Hmm.
So that is something, it's a data is given to us. Now we have to ask, like, do you want me to take up all questions of 5? Is it?
So the B part.
The B part is f of x plus g of x is divided by h of x, right? That one.
Yeah, yeah.
Okay, so what will be the maximum possible degree of the remainder when h of x plus g of x is divided by h of x, correct?
Yeah.
So here, this is the case, f of x plus g of x divided by h of x, f of x. Sorry, just give me a minute. F of x plus g of x, and it is divided by h of x. Okay. So now what is the problem here, Priyanshu?
Okay, I think gx would be the remainder because hx would divide fx and only gx would be left. Is that the way?
Yeah.
Okay, so now I got it, sir.
Okay. So this kind of problem you can actually expect in the quiz as well. Okay. So you will have something twisted in this, or a sentence, and you will be asked something question like this. Okay.
But the information would be given to us, like degree would be given to us.
Things will be given to you. It will be based on the
Sir,
standard only, like, yeah.
and there was one question in the grade assignment week 9 about the gold one.
Which thing?
About the amount of gold that is produced week 9.
Yeah. Graded assignment, right?
Amount of gold. So
Okay.
there, the
Excuse
answer
me,
was
sir.
coming 740
Yeah.
for total
7,
year.
sir.
In the same question,
On
the
which?
degree of f of x plus g of x will be the same as f of x, right?
Sorry.
The degree of f of x plus g of x,
Yeah.
that entire function will be the same as f of x, right?
Yeah, the degree of this will be same as f of x, correct?
So then the remainder should be 0, right? Because you're dividing the same degree by same degree. Like degree of f of x plus g
there
of
is
x
no
will be 5, and degree of h
the
of x
remainder
will also
doesn't
be
consider
5.
degree. The remainder doesn't consider degree.
Srinath, we are not dividing the degree, we are dividing the whole function, and since it is given fx is divisible by hx, then gx will be remainder.
Oh, okay, got it. Yeah.
Yeah.
So if you can see the solution part of the gold question week 9 graded.
Okay. I'll just take up that. Yeah, please. So I'll write down the function here for you.
Yeah.
Here f of m is given to us log 10 m plus 1 minus half of log m plus 1 times 0.01, right? And here here m represents some month days, right? M represents days, and f
Yeah.
of m represents the weight in kg.
So when we solve the solution, the minimum m would we would get would be 2 only, 2.
Okay.
And so for 1 year it would be 730 kilos.
For 1 year it will be 730 kilos.
Because 365 into 2.
Yeah.
And they have said in the solution that it can be more than 2.5. It can be more than 2 for minimum 20 days. How did they get that 20 days?
1 minute. So which part A, B, C? Can you tell me where?
B part.
In the solution?
B part.
B part. Okay. Now total of gold is like that part you understood, right? The simplification part
Yeah,
of this line function. Yeah. So you get
Yeah.
something after simplification. This thing.
Would need help, no?
This is what you get, right?
Yeah. Yeah.
And
So it's
now
already done
here
with
the
some
minimum
C
value of
file.
f is 2.
Check mom's phone.
Correct. At what value of m?
Get it here, you won't be able to check.
B part.
Yeah. So when, no, that is fine. When m is 9, you get f of m is 2, and this is minimum, correct?
Can you repeat?
Hello.
Someone mic is on. Can you mute it?
Yeah, I think it's muted.
Yeah.
Yeah.
So how did we get 740?
How did you get 740? Okay. So basically when you see this function, okay, when you give the plot for it, like of course the minimum value is
Then
2
what?
and the number of days are 365,
Asking it.
right? Hello.
Can you
So
please
this gives you in
mute,
turn what?
can you please mute
730.
everyone? There's a lot of background noise.
Yeah, but you are asking how it is greater than 740, correct?
Yeah.
Yeah. So if you remember, this 2 is the minimum value, right? And this function is increasing after some point of time.
Yeah.
Yeah, wait a minute, just a minute. I'll just connect my charger. Yeah.
Sir, here I am having a little doubt, sir. Why we are multiplying 365 by 2?
It's because minimum value is 2 here. Throughout the minimum value of the gold.
Because m is the mth day, that means m equals to 9 is the nth day. So what will the value of at first day? That is m equals to 1?
That is definitely going to be more than 2.
Okay.
Yeah. So it's like basically when you see the graph of this, it's going to be something like this. Okay. So this is that minimum value 2 kg and this is at when m is equals to 9. Okay.
Okay, sir.
Yeah.
So when you this as the minimum value and you are considering m is number of days, right? So throughout the year it is going to be minimum value, it is going to be 2. So definitely it is going to have a larger value, isn't it?
Yes, sir. Yes, sir.
Yeah, that's why we
Sir,
take it.
So can we look at
Okay,
question number
understood,
4? Question number 4 in the graded assignment.
Sir, I have
So
one
how
more
did
doubt
you
here.
got?
Sir,
How
then
did you got
how
740?
Okay, I'll take up question number 4 in
it
a
will
while. Somebody has a doubt.
How
Sir,
did you got 740?
sir, is there an order that we can ask the question? I had raised the hand much earlier.
Okay, so basically like I am not saying the raise hand thing. So yeah.
Okay.
So can you? Who was that?
So,
Sumit, is
sir,
it?
so this
Sir,
is
you
the
said how
problem.
did you
I
got
have a
740?
question.
There was
Mhm.
730
Sir,
and
can we
how
finish
did you
this?
get 740?
Sir, can we finish this first? Sir, can we finish this first?
Yeah.
sir,
We can finish this and then
I
we can
have
move.
I have doubt in this question itself.
Okay. Yeah.
How we are getting this
How did
740?
you got
That it should be
740?
greater than 740. It could have 735 or 750. How we are deciding this? It should be greater than 740.
Okay. Right. So now you take up the function here. Okay. Now this function. Now we know for 9 we are getting this value, right?
Sir, how we are getting 9 as the minimum value?
9 is the minimum value.
Yeah, how you are determining that m is equal to 9 is the minimum value, the minimum amount of gold it will give?
Okay. So basically you need to solve this equation in order to get that thing, the minimum value of this. Now
Okay.
let's, yeah. Hello.
So we can use the AMGM inequality.
That can be done, but yeah, you can actually see this value. Like you can just solve this equation, you will get that value.
Sir, how you got
did you
2,
got
sir? Can
exactly
you
the
explain
740?
Sorry.
how did
Sir,
we
what
get
exactly?
2 there?
How did we get this 2 here? Is it? So basically, like we got the minimum value. Now if this is the graph for that above thing, now this is the minimum value. So for M, when it was 9th day, the minimum value was 2 kg. But it is never going to be lesser than this, right? Throughout the year, the value is never going to be lesser than 2, isn't it?
Okay, but where is it given that this 2 kg in the 9th day?
Sir, how did you got 740 exactly? How did you add up 10 kg?
Sir,
You
how
won't
did
get
you got that,
740
sir?
exactly there. It's just an intuition, like, okay, if this is the minimum value, definitely it's going to be 7. So, okay, now let's
So
take
it
up
can
a
be
different
less
value.
than 740 also. It
Yeah,
can be
I'll tell you how.
735.
I'll tell you how. Since this is an increasing function, first of all, what you will do is you'll have to first understand from where this value is actually increasing and where not. Okay. So when I just take this value, f of n, and when I take the plot of this, when you plot this function, this will be an increasing function. So when you take m as equals to 99, so 99 means on 99th day, what will be the fm value?
Okay.
So what will be fm value?
10
log
It will become 100.
100.
1 by
10
log
plus
10, 100. So this will give you what eventually 2 plus 1 by 2. This will give me 2.5. And this is increasing function. So thereafter the values are going to be increasing only, isn't it?
Also, then one more doubt in the log function. Whenever we get the
Yes.
value of x, we have to put it back in the function to check or.
Sorry, could you repeat again? Sorry.
Whenever we get a log function and whenever we find the value of the x of the log function, do we have to put it back every time in the equation to verify whether it is correct or not? Or
the x value. Okay, so you are talking in context of in composite function, like when you get that, let's say you got
no,
the value of x
no,
as
in the
4
log
and minus
function
1.
only, mainly in the log equations when we solve the logarithmic equation.
Yes, definitely. You have to put in and you have to check with the domain.
And if it comes as 0 equal to 0, then also we can't take it.
Yeah, you're gonna take it at that time.
It can be taken when it is all values except 0 equal to 0.
You have to make sure the definition of the log function is, it's satisfied. So you know that the domain for this is like 0 to infinity. You cannot have the value. It will be greater than 0 basically, right? You cannot take 0 value definitely.
But even when LHS is equal to RHS for 0, then also.
Even when, sorry? LHS is equal to RHS.
Yeah. When we verify that, when we put back the x value in the equation.
Okay.
If
No,
we
so Priyanshu, like the general notion what you can keep with you is whenever you are taking a log problem, whatever value you get after solving it, okay, you first put it in the equation and then you have to see that is if it is greater than 0 or not. If it is greater than 0, otherwise don't proceed. Even if you get 0 or whatever, okay, don't proceed if it is not greater than 0. If the function, when you substitute the value is greater than 0, then proceed. Okay, Priyanshu?
Okay.
Yeah.
In
And
the verifying condition.
Yes.
In the verifying condition. In the verifying
Yes, in the
condition, you have
verifying
to.
condition. So when you're verifying,
Okay.
when you're verifying it, substitute the value of x and see if it is greater than 0 or not inside the log functions. Okay. If it is, then proceed. Otherwise, no need to proceed.
Sir, from the first line to second line, how did we come? Can you explain that, please? I
First
find
line to
this
second
log
line.
thing.
This
Yeah,
one, this one is it?
yeah,
Oh,
yeah.
okay, fine. Okay. So this part, I'll take it here. So this is going to be, is it visible?
Yes, yes.
So this part is fine, right? This is
Yes,
no
correct.
problem. So I'll take up the second part here. So now what I can write this as log m plus 1, 0.01 to the power of minus half.
Correct.
Then I can write this log m plus 1. I can write this as 1 by power of minus half.
Correct.
Then I can, since this is negative, I can reverse this function.
Yes, you can.
Right. So this will turn out to be again half. Sorry. So now
Oh,
this
if it
is
negative, you're reversing, meaning what does that mean?
okay. I'll tell you what. So basically, this can be written in the sense this is. Take it here. So when I write 5, when I write 1 by 5, this is equivalent to saying 5 to the
5
power
raised to
of
minus 1.
minus.
Correct.
Right. When I say this 5 square,
Okay.
then I can write this as 5 to the power of minus 2.
Correct.
Correct?
Correct.
Similarly, when this is half 1 by 2, so I can write this as this way.
Okay.
Right? So now what I can do is, similarly, I can take this as m plus 1. Now this can be written as, so when I take this 1 by 100 to the power of 1 by 100 to the power of half. Correct? Okay, you got confused there. Okay, fine. We'll take it up here. So, okay, so how, so till now it's fine, right? Till
Yes,
here
correct.
it's fine?
It's
Okay.
fine.
So now this I can write this entire function as log m plus 1, 1 by 100 half, correct? No problem till now?
Yeah, correct.
That's
That
fine.
minus you inversed it. Okay. Okay.
Yeah. We can write this as
1 by 10. Okay, correct.
correct. Then
Yes.
I can write this as 1 by log m plus 1.
1 by 10. Correct.
Huh?
Correct.
Is it fine?
Yes.
Now all you need to do is you take the, the reciprocate the things. Wait, I think I missed it somewhere. Wait.
And even I want to know how that base became 10 and m plus 1 came to the right.
Okay, I get it. Right. I'll do it freshly here for you. Okay.
Yeah. Who is designing all these questions, sir? Too much brain.
So you take this log 10 m plus 1. Now this part is
1 by
I'm
log.
taking it here. So this I can write it as log m plus 1. Let's take it in this way only, 0.01 to the power of half. Okay.
Okay.
Minus half.
Correct.
Then I can write this further as 1 by log m plus 1, 0.01 to the power of half. This thing will be same.
Correct.
Okay.
So how 1 by?
Because that
So
minus sign
the power
on
is power
No.
outside the log.
minus sign in the power. So
This will go here.
So yes, if the minus sign is in the power, then we should have written whatever the function
this
log
way.
is operating upon. We should have written it. Yes, sir. Yes, like this.
This is the way. Okay. That is what I missed at that time. I got some wrong answer.
Correct.
Okay.
But
Thanks,
it is
thanks for
very
correcting me. Yeah. Hello. Hello. Was it
yes,
Srinath who was asking me? Yeah, Srinath.
Srinath.
Yeah. So now we can see here that I can write this in the form. Now it will be simply you have to substitute this value. So you can just write this as. So this will become
1 by 100.
Yeah, 1 by 10. Then basically this part will come up.
Oh, correct.
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 Then you get it, but these things will go down, and then you
So
will have
1
10
by
on the top.
100, no, sir. 1
Right.
by 100.
No, he took the
Yeah.
two.
So I have taken 2 square here. I have taken it out here.
Okay.
Yeah. So then I'll have this.
1 by 1 by 10 is 10. Correct.
Then this part will go on the top. It's just like 1 divided by 1 by 10 can be written as 10. You have doubt here itself, Srinath?
No. It's clear.
This part is clear? Okay.
Yeah.
Okay.
My doubt is how the 10 became the base. That is.
Yeah. Now I'll tell you.
That was, I think, simply the base change
Simply the
rule
formula
which
we are
was
using. Yes.
discussed.
I'm
Yeah.
not aware of that rule.
All right, no problem. So what we can do is now, if you know this formula, that is now I like if I have a function log AB, okay,
Okay.
and now there is a formula called change of base. So log B by log A. Now you can give base whatever you want, okay.
Okay.
So this is like, now I can give it as B here. Let's say this is B in this case, okay. So this will become 1 by log BA. You know this formula, is it?
No.
Change of formula. Okay, change of base you don't know. Okay, I'll tell you what it is. So basically, like when something is given to you, like this part, let me say I'll take a numeric value, log of 5 to the base 4, suppose.
Okay.
Then this is equivalent to writing log of 5 to the base whatever you can give.
Okay.
You can give it, let's say 10 log 5 to the base 10 again, but you have to make sure the base for
By
both are
4,
same.
no?
Sorry, 4. Correct. Thanks. So you have to make sure that the bases are same. So you can give it any base here. You can give it as 5 also here.
Oh, okay.
You can give it 5 as well here.
Okay.
So now that is what we are doing here.
Okay.
So now what we'll do is again changing the base here. So log 10, I will take base 10 here, divided by log m plus 1 to the base. You got it?
Okay. I got
now
it.
Log, so this is nothing but 1 by log 10 m plus 1.
Oh, okay.
Yeah.
Okay. Okay, done.
So yeah.
Can we
So
take
somebody
question
had
4
doubt
now?
in question number 4 of graded data strategy.
Sir, before that, just one question.
Yeah, please.
In one of the lectures, the Madhavan sir said in an adjacency matrix, the maximum number of non-zero entries can be 1, but it might not be. It is less probable, but the maximum number of non-zero entries is n square.
That is in week 10, right? That doesn't mean.
So based on that, in graded assignment, I chose n square, but the answer is given as n into n minus 1. I just want to understand the.
You can't have an adjacency to yourself, so you have to minus n.
So meaning there is no self
loop. There's no loop to yourself, right? There's no edge to yourself.
But the question is, what is the maximum number allowed? So that is n square. N square, no?
So
because
you
the
cannot
professor specifically said so that the maximum number of ones can be n square, but it is less probable.
The size of the matrix is n square.
Okay.
The number of edges that you can connect will be excluding yourself, A to A,
correct.
B to B. So it will be n square minus n.
Okay. So that is why n into n minus. Okay.
Okay. Now it's fine.
Hello, sir. Hello, sir. I have a doubt in quiz 3, question number 3.
Sir, I want to take up the graphing question first.
Yeah.
I have sent the equation on the chat. If you want, I can speak it out.
Okay, I'll just have a look at chat.
Yeah.
Yes,
So
sir.
this is like
There's some substantial, lack of understanding when it comes to graphing logarithmic functions. Other types
okay.
of functions, it's pretty straightforward. But when it comes to some kinds of logarithmic functions which have different kinds of bases, then it becomes a little bit difficult.
Okay, so fine. What I'll do is I'll quickly take out that thing, and then I think that will be fine. Yeah. Is this the function?
Yes, sir. This is the function.
Okay. So what is the doubt in this? So you want to know the graphing part of this, is it?
Yeah, graphing part of this particular equation. So maybe as you explain normally, I would have some doubts which will automatically get clarified, and that will help me to understand the concept better.
Okay. Yeah. So basically, like when you're doing the graphing part, okay, so you won't be going exact of it. So here, this thing will talk about the multiplicity of the roots, isn't it?
Yes.
So from here, how many roots are there? Can you tell me from this data?
Yeah. So
you can equate this to 0. So
minus
one
2
root will
plus
be at
8
0. Yeah, minus 2
plus 8.
plus 8. Yeah. Minus
The other
3 by
would
2.
be minus 3 by 2. Yeah.
It will be somewhere here. Correct?
Yeah.
Okay. Now, what is its degree? Total degree? 2 plus 1, 3 plus 1, 4.
7.
7. So this is going to be an, it's basically not even, right? Right? It's not even. So it's going to cross the x-axis, correct? If it is not even, had it been, sorry, if it is even, it would have been bounced, or it, like it would, the ending would have been on the same side. Forget about the crossing part. The end would have been on the same side. If it is an even function, so for even function, the ending is always on the same side. So it can, let's say, if I take it x square, so x square is nothing but an even function. Basically, the power is even here, right? X square. So you will see its ending is on the same side, here and here. But had it been an odd power, it would not be on the same side. It will be on the other sides, like this. If you see the ending.
Right. Right.
So here, if you see the power, like this is going to be 7, right? So 3 plus 1. So it's going to be a 7. So obviously the endings would not be on the same side. And you can determine it's, since this is like when you divide this entire thing, you can see this is going to be a negative one. So we know for x cube, how does the graph look like this, right?
Yes.
Then had it been like minus cube, how this graph would have been?
It would be flipped around the y-axis.
Yeah. So this would have been something like this, right?
Yes, right. So, sir,
so what
first
you see
doubt
the
comes
ending
over here. First doubt comes over here.
Okay.
How we are deciding just looking at this particular equation.
So that's what I'm trying to say. So
Yeah, okay.
what you have to do is, like, you have to keep some standard graphs in your mind. For x square, how does the graph look like? For x cube, how does the graph look like? Right?
Yes.
And how does it changes when it is positive, negative, positive, and negative? That is something you have to keep in mind.
Correct,
so this
correct,
is here,
okay.
like, if this is going to be negative, then obviously it is going to be somewhere of this type.
So, sir, where have you found the hint that this is negative?
Look at the coefficient of this.
Minus sign.
So, sir, this minus 5.
Okay, I'll tell you how.
Okay.
See, when you take the square part of this, this is going to be positive. X square.
Yes, okay, fine.
This is also positive.
Yeah.
The cube of this thing is also positive. This will become like 8x cube when you expand this.
Okay.
Only negative is here. Correct?
Yes.
So negative into positive of all this value will make it negative, correct?
Negative.
Yeah, so that's how we'll get to know.
Fine. So we also read that we have to focus on the leading coefficient. So
yeah,
if we expand this particular function, what you are trying to say is the shape of the figure will depend upon minus 5 multiplied by 2x cube. Am I right? That is how you are deciding, correct?
So, yeah, who is this? Who wants to speak, please? Anybody? Okay, fine. I'll take it. So basically, Apul, right?
Yes.
Yeah, Apul. So what we have to do is, see, it's not just this.
Stand up in infeasible solution.
Actually, for this part, yes. Why? Because this is going to anyways going to be positive one, and this is going to be positive one again. The coefficient, the leading coefficient. So, Apul, what you have to see when it is told, like you have to understand what is the leading coefficient term. What we mean is whether it is positive or negative. Okay.
Yes.
Yeah. So in this part, it's going to be negative or positive in this question.
It would be negative if we are multiplying -5 by 2x whole cube. Correct? That's how you are approaching. Correct?
Right. Right.
Yeah. Okay. Fine. Got it, sir.
Yeah, that is only the way. Yeah.
Okay. So this would be the shape. One of the edge, one of the sides would be on the second quadrant, and one of the ending sides would be on the fourth quadrant.
Yeah. Correct.
Okay.
I mean, quadrant
Fine.
saying is not right. You can say like negative y-axis and positive y-axis.
Yeah.
That should
Fine.
be,
Okay.
yeah.
Okay.
Yeah. Yeah. In this case, yes. That definitely that should be it. Yeah. So somebody had doubt in logarithmic graphing of
No,
the
sir. How
logarithmic.
we will proceed? So maybe you can just complete this whole question.
Okay. Okay.
Sir, in the same graph, I have one question. Can I ask? So, hello?
Sir, can you complete this question?
Yeah, yeah, please. Yeah. So what it will be here is Apul now. So this can be something like this. Okay. You can have some, real roots as well. Okay, I'll just see the chart. What was the graph given to me? Just give me a minute, Apul, okay?
Sure, sir. Sure.
So this, if we can plot this, it can either go down or it can go from here, depending upon the coefficients here. So you can just have a rough diagram of this, not necessarily it will be, the exact value. Then something like this. Okay, Apul?
Yes, sir. I'm looking at the screen.
Yeah. So something like this.
First line you took it, and then it was.
You can take it like this or something. Yeah, Apul, please.
So, sir, the first value is -5x. Okay.
Okay. So first value is -5x. So let's say this was somewhere.
So, sir, the first value -5x, that would be the vertex at x equal to 0, right? So, yeah, this is the confusion. How have we decided whether the graph would be, from which side will it be coming?
So as I told you, if it is x, the graph would be like this. Has it been? Yeah. So had it been
No, so
like
for this
minus of x
particular
cube?
vertex, for this particular point,
Okay.
for this particular point, how we are deciding the curve?
Like how does so we can only get to know like where does this thing end and which all points it covers. That's all we can know.
Sir, can I add something here?
Yeah, please.
There's something called as multiplicity of roots.
Right.
Okay. So around the roots, if the behavior of the multiplicity is odd, let's say it's linear, so it will cross the x-axis. If it's quadratic, it will touch the x-axis and turn around. And if it's cubic, then there'll be a slight bend, but it will cross the x-axis. So you have to look at each of the intercepts and then decide.
Yeah. So Apul, for you, basically like we have seen one of our roots was somewhere here at 8, right?
At 8, yes.
Yeah. So
correct.
so here, and you can see it is x. It was given x minus 8, and then you
Correct.
have 2x plus 3 the whole cube.
Whole
Correct?
cube. Correct.
Yeah, and then you have
X plus 2 whole square.
the whole square, and then you had
And then
minus
minus 5x.
5x. So what we notice here is this is a straight line.
Yes, right.
So this will be something going just like this, okay? And
Correct.
x minus
Okay,
2 the
fine.
whole square it is. So if I take it here, x minus 2 means that will be somewhere here. If it is, this is minus 2. So, and this is square. So as we know, like for square, it is going to, you know,
Quadratic
it's going to
parabola.
yeah. So it's going to be a parabola. It's going to bounce back, in other words,
Okay,
right?
fine. Yeah.
So when you take this, so it might be something like this,
Yes, fine.
right? Okay. And when
Now
you
for
take
minus
this part,
5x, yeah.
yeah,
For
that will
minus
pass to
5x.
0. This will pass. This will just go through as a straight line. This will go as a straight line.
Why will it go through 0,
Sir,
sir?
at 2, it will be a down parabola, na?
Sorry?
Downward parabola, I think. Because
Why?
minus x
No,
square.
we are just taking this part. Had it been minus x here, then it would have been different case. It is
Okay.
x plus 2 the whole square, so it's going to be like this, okay? Now let's
Okay.
take up this part.
Sir, over
yeah.
here, why are we considering x? Why are we not considering minus 5x?
That I will come. That we will come here. That will pass through here, right? And this is going to be a straight line again. This is going to be passing just like a straight line here.
Apul, if I understood your question, your question is why is it not 5, minus 5 or 5, and why is it 0? Because you put minus 5x is equal to 0, so you get root x is equal to 0. And that is why it will pass through 0.
You got it, Apul?
Okay. Okay, fine.
Yeah.
I see.
And
okay.
Yeah. So this will
So for
something
x equals to 0, for x equals to 0, what would be the shape of the line, please?
X equals to 0, is it?
Yeah.
It's going to be this part.
It is y-axis.
It'll pass to the origin.
Sir, please draw in the same graph. Please draw in the same graph, sir.
Okay, fine. So this is going to be for x equals to 0, it's going to be a y-axis. So this is something going to be here.
Okay.
Yeah.
X equals to 0. Fine.
Yeah. Now you have something called this part also, right? So this will give you x equals to 0.5. So this root is somewhere at here, right? 1.5 minus 1.5, and you know it is cubic. So it's just going to cross this, isn't it? And then this will go through 0 because of this factor. And then it will go to some extent where it will come back like this. Okay.
Okay, fine, sir. Got it.
So can we discuss question number 3 of quiz 3?
Thank you, sir. Thank you very much.
Yeah, you're welcome.
Before that,
question number 3 of
quiz 3. So I have just small doubt.
Quiz 3. How come quiz 3 you have?
Yeah,
like
mock quiz 3.
Mock, okay. Paper came out already.
Sir, after this, can you take up question 4 from graded assignment 9? I just
Yeah,
have one small
somebody
doubt.
has been asking me from long time. Yeah, I'll take up that.
Asking you.
Yeah. of graded assignment, right? So first I'll take up that because you're asking for a long time, right? I'll take up that and then we'll go to the mock quiz.
Have you?
All right. Yeah. Was it?
Okay, sir.
Yeah, because he's asking
Yes, sir.
for a
Yes,
long
sir.
time.
It's
Yeah.
fine.
Graded assignment, week 9 graded assignment, question number 4, right?
Question 4, yeah. So
Yes, yes.
it's a composite function, composite logarithmic function. Should I?
Yeah, I have the question in front of me. I'll take up.
Right.
Sorry, could you just repeat which question? We can also open it.
Yeah.
Question 4.
Question 4, which week?
Graded assignment 9, week 9.
Okay.
Graded assignment, right?
Yes.
Okay, fine. So yes, so basically here we are given with, I'll write down the function so that everybody will have the access. So f of x is equals to log 2, then you have minus x square plus 4x plus 12, right? And then we have to find the range of it, correct? Who asked me this question?
This is Sumesh, sir. Sumesh.
Yeah, Sumesh. So this is the question, right? You're looking for?
Yes.
Okay.
And I have
Yeah.
a related question also. So when the quadratic equation, the leading term is positive and not negative. So both these.
No. It's negative.
No, I'm saying what if the leading term is positive?
Okay.
Then how would it behave? I think there is a difference between the two behaviors. That's what I understand.
Can other person please mute except the person who is asking? Yeah, so you are asking like how does it behaves when it is positive, right?
Yes.
Okay, so we can take that. Okay. So now had this been positive, then how it would have behaved, right? So let's take this log 2 x square plus 4x plus 12, right? And then we had to find the range of this. Okay. So again, I would have first drawn this graph. Okay. So could you help me out in getting the graph for this?
Would it factorize? That's what I'm thinking right now.
Yes, sir. We have to find the domain of the quadratic equation first.
Yeah. So basically, this is not factorizable. I feel like if you find the discriminant of this,
Can you make it minus 12? Then it will be factorizable.
Okay, you want to take it as minus 12.
Minus 12, yeah. So then it will become plus 6 minus 2.
Okay.
Yeah. Hello.
Yeah.
Yeah.
Okay. Take it as minus 12. So now when you factorize this, so
now it will be plus 6 and minus 2.
Yeah. So plus 6 and minus 2.
Yeah, x plus 6 plus 6x. Okay. So yeah.
X plus 6 and x minus 2.
X minus 2, correct.
Okay.
So x will be minus 2. Oh, sorry, 2 and minus 6 then.
So can you help me out with the graphing of this? So how does this graph look like when I draw the quadratic function?
So
there will be asymptote at x equals to 2 and x equals to minus 6.
Correct.
That is right. So this is how this is going to look like, right?
Correct.
But we are excluding, sir, minus 6 to 2.
What we are excluding?
Correct. That's the point I
want
to
clarify. You are a bit far. We are going step by step, right? Yeah. So this is fine?
Yeah, this is fine.
Yeah, this is fine.
Okay. Now we have to look for the next, like how does the graph, how does the log function look like, right?
Okay.
So for doing that, we have to make sure like what is the values that it can take. So now we know that x plus 6 and x minus 2, it has to be greater than 0, right?
Yes.
For the log function to be defined, correct?
True.
Yes.
True. Yeah.
Yeah. And we know how does the log function look like? The graph for log, this is something.
Yes, either increasing, either decreasing.
Yeah. So if this
Yeah.
is log, if it is like log x, let's say to the base 10 or 2 or anything, like if it is lesser, if it is greater than 1, this is how it's going to look like. And
Yes.
if it is
Okay.
lesser than 1, then the graph would look like something like this.
Right.
Okay.
Yeah.
But in both cases, it will pass through 1.
Yeah.
Okay. Yes. Yes.
Yeah. So we are aware of that. So now here we can make sure like here x plus 6 is greater than 0 and x minus 2 is greater than 0. These are the two things given. So now what will be those intercept value? Like the log function will be defined only for those functions, only for those values of x, not any other. Okay. So now
So
we know
x
that from here we will
greater
take
than
x,
2, x greater than 2 and x less than 6, right? These two values.
x greater than minus 6 and x greater than plus 2.
Yes.
Will it be greater than minus 6 or will it be less than minus 6?
Less than.
It
X
should
will
be
be
less than.
why?
Because if you take x greater than minus 6, so let's say you take x is equal to minus 5, right?
Okay. Yeah.
So then the quadratic will become negative actually.
Yes, sir. Quadratic will become negative, sir.
So that's why the x has to be greater than 5, right?
No, it
No,
has
sir,
to
it
be
should be
minus
less
6.
than
minus
less
6.
than
So,
minus
But
6.
look at the other
Minus
condition.
6
It says
should be
x
there.
should be greater than 2. So don't worry
No,
about
no.
x greater
So
than minus 6. It should be x greater than 2.
no,
Yeah,
no. There
With
are
yes,
two
x greater
conditions here.
than minus 6, anything falling between minus 6 and 2 would also be avoided. So it would be just x greater than 2.
no, it's a quadratic equation, no? So it can take negative value, which is plus and
Right.
minus.
It's or,
Correct.
not and.
Yeah, I'll
Correct.
tell you. See, basically, like we can take two values here. No, so first case is you have to make sure that this is greater than 0. So when will it be greater than 0? When both of this is greater than 0, or when both of this is lesser than 0. Correct. Then only this
Correct.
will become positive.
Correct.
Okay, I
Yeah.
understood, sir.
Yeah. So when this is the condition, here what do you get? X has to be greater than what? Minus 2, because this is something you're getting. X greater than minus 6 and x greater than 2. So it's good to take x greater than 2, right? Because minus 6 is here and 2 is here, and we have to take all those value which is intersecting here. So what are those values which will be intersecting? If this is going this way and this is going this way, then it has to be from 2 to infinity, right?
Right, sir.
You got it? Who asked me this question?
No, sir. This is Sumesh. There's still some one point I
Okay,
didn't understand.
I'll write it down freshly for you here, so that
Yeah.
I mean, this is really good question because you will have questions similar to this in your quiz, so you can pay attention for this. So now you got something like this, okay? Now x plus
Right.
6 greater than 0 and x minus 2 greater than 0, okay?
See, my
So
point is,
two
if
cases.
x plus 6 is x plus 6 greater than 0, yeah, these two cases, correct. Correct.
We'll take up two cases here. When will this be positive? When x plus 6 is greater than 0 and x minus 2 is greater than x minus 2 is greater than 0, correct? And another thing is x plus 6 should be lesser than 0 and x minus 2 should be lesser than 0. Had these two been lesser than 0, then this would become positive, correct? This part?
Yes.
In both the cases, it will become positive.
So,
correct.
Hello. So once again, didn't get it. So once again, repeat.
Okay. Now we have to make sure this is positive, right?
So from x plus 6 greater than 0, right? Once again, repeat from there. No, sir.
I'll tell you. You got till here. This part you got it. How did we factorize and everything? Now, can you tell me why this should be greater than 0?
Yes, we calculated the roots. Yes. Why?
Okay. Now, can you tell me why this has to be greater than 0?
Hello.
Yeah. Why this 2 has to be greater than 0? Why?
Should be defined.
Yeah. For the
Because
log
they are
function to be
roots
defined.
and
Hello, sir.
roots of the quadratic equation.
Hello, sir.
No.
Sir,
That is
in the
not the
question,
reason.
sir, hello.
Yeah.
Sir, in the question, it has been minus x square. It will be minus x square. In question, it is minus x square.
Minus x square.
Yes, sir.
No. We
No. We are doing some other part. Similar
variant of
question
this
we are
question, not the same question. Yeah.
Okay.
Yeah, right.
Okay.
Okay. So now we are just trying to understand what will be the domain for this, right? So why I asked you a question like why this has to be greater than 0? Why?
And because the domain of any logarithmic function is from 0 to positive.
Infinity.
Yeah.
So it's defined for all values of r greater than 0, right?
So either it has to be plus into plus or minus into minus.
Exactly. So that's what I'm trying to do here. So we are taking two cases here. So from here, if I solve this, so this gives me x has to be greater than minus x. And this from here, this part of this x has to be greater than 2. Now what do you see? Now if it is about greater than, then this is minus, and greater than means infinity.
Yes.
So minus 6 to infinity and then 2 to infinity. What will be the intersection point of this?
2 to infinity.
Exactly. So this is going to be 2 to infinity, correct?
Okay.
Yeah, you got it. So you have to take the intersection point of this. So this can be written as minus 6 to infinity, and this can also be written as 2 to infinity. But what is the intersection point of this?
2 to infinity.
Exactly, 2 to infinity. So we will take that value from here. So this is one condition. Now from the positive cases, so x will be positive only in these values. Now we can check this out. Now let's say if I take x value as, let's say, since 2 is not included, so let's say 3. So will this 3 make it positive? Yes. So definitely this is the one which is playing the role here, isn't it?
Correct.
This is for all the values of x greater than 0, this is anyways going to be 0. And here for all the values of x greater than 2, this is going to assume the values as positive, right?
Yes.
That will be something suffice from here. So the value for it to be positive, the x has to be from 2 to infinity, correct?
Correct.
Sir,
Yeah.
For the value between negative infinity to negative 6 also the values will come
That will
positive.
No, it's not going to happen. Let us take as minus 5 here. Okay, x is equals to minus 5.
Sir, minus 10. Take minus 10.
Okay.
Now
So
he's
take
handling the
any
plus
value
into plus scenario now.
Yeah. Let me come to that part here. That we will get it here.
Now we are handling the plus into plus.
Yes, we are handling plus into plus. Now we will take up the negative part. Now let's try and understand from here. So what we get, x is lesser than minus 6, and here what do we get? X is lesser than
2.
Right? So when I draw the number line here again, so 2 is somewhere here and 6 is somewhere here. So this is all values that x can take, and this is all values that x can take. So what is the intersection point? This
Minus infinity to minus 6.
Minus infinity to minus 6.
Minus 6 within open interval.
Yeah.
Minus infinity to minus 6.
So now we got to know, like, these are the only values wherein I can play around for my log function, right?
Right.
Correct.
Yes, sir.
Okay. Now we know this since, yeah, who is this?
Yeah. So make sure. So
Now
this, so we found out the domain right now, right? Now we have to find out the range as well.
Domain right now. The domain is from, I'll just write it down here, minus infinity to minus 6 union 2 to infinity, correct? This is our domain.
Correct.
Right.
No problem with the domain till now.
No
Yes,
problem.
sir. No.
Okay. Now let's go. They are asking what about the range of this function, correct? So it's always good that we can draw the graph for this. So now I'll draw the graph here itself. So for drawing the graph, I should be, since log is something wherein we get the asymptote, right? And when will I get, like, if this was my f of x, and this is something I got log 2 x plus 6 and x minus 2. So what do I notice from here? When x tends to minus 6, what do I get f of x? Or in other word, when x becomes minus 6.
Minus infinity.
Minus infinity.
When I give, yes.
It would be
Become what?
At
minus infinity.
Yeah.
Minus infinity,
Okay.
right? That.
Yeah.
Sir, why you have taken x minus 6? It would be
Because
x
at
plus
that
6, right?
value, no, because at that value, this will become 0, and then I'll get my asymptote.
The function we are considering is x plus 6, log of x plus 6, not x minus 6.
Okay, let's take it.
We are taking the x value.
Yeah, okay, fine, sir.
Zeros
Right.
of the quadratic.
So at what value, at this will become 0? Can you tell me? X plus 6, at what value it will become 0?
Next equal to minus 6.
So when my x is going to minus 6, where is my f of x going towards?
Minus
I told you in the beginning. So we'll just take up the log function. How does it look like? Log x, the graph of log x is something like this. And this is our 1. Okay. So what do you see when this is my log x function? Correct? So when my x is becoming 0, where is this value taking me to? Minus infinity or plus infinity?
Minus
Infinity.
So my log x will always take me, when x is tending to 0, or that x value is going towards 0, then at that point I notice that f of x, the log function, tends towards the negative side. Similarly, with this understanding or with this knowledge, we can get to know what is f of x. Now, similarly, when I give x when it is going to minus 6, it gives me what? F of x equals to minus infinity. And also, when x tends to plus 2, at that point also I see what?
Minus infinity.
It is again going to minus infinity. How can this happen then? There should be something happening, right? So now here my domain comes into picture. Now if I take this domain,
this is a discontinuous function, right? Then log of this.
yes, this is discontinuous.
Okay.
So how does the graph still look like? Let's see that. Okay. Should we go ahead? Have any?
Yes.
Yes, sir. Move on.
Okay,
move on,
fine.
please.
So now we have this. Now we got our domain and we got to know where our asymptote is. At x equals to minus 6 and at x equals to 2, I see f of x is being negative. So that means, but I know how does my log 2x looks like. I'll tell you again, remember this always. Log function, log x is something like this. If this is my a for all values of a greater than 1, okay, and this is going to be this way, and it's going to be this way for log for all values of a lesser than 1. Okay, so in other words, if this is log 2, then log 2x, then the graph looks like this, and this is for the value log lesser than 1. So I can take lesser than 1 is, let's say, log of 0.2. So the graph looks like this in that case. Okay. Any
In
doubt in
second
this?
case, a will not be less than 0, no?
In which case, yeah. Any doubt in this? No problem. No, we can move ahead.
Got it, sir.
Yes, sir. Yes, sir. Move on, sir.
Yeah, clear.
Okay. Okay. So now it is given to us. It is given to us. It is log 2 of something, correct? Log 2 of something is given to us. So how does graph will look like? It is something going to be like this, right?
Correct.
Yes, sir.
Right?
Correct.
Yes,
And I
sir.
know, and I know my domain. My domain says what? It is from what value?
2 to infinity.
2 to infinity. So when I take the positive values of it, so this must be somewhere, like this value. This value, my asymptote is at 2. So this is 2.
Right.
Right?
Right.
Right.
Yes,
Because
sir.
at this value, for 2, this is forming an it's being asymptote here. So this is something it's going to happen. Right? And for at minus 6 also something like that it will be happening.
Right.
And the graph will go like this.
Right.
Okay. So I got my graph for log 2 of something what we have got here. So this is how the graph looks. Now we know what is range. Range is nothing but all those values of y. So what are the values of y for this?
Sir, just one question, one doubt
All
over
real.
here.
Yeah.
Sir,
So the range
it's
should be
a
now
conceptual
minus
doubt
infinity
that I'm having.
minus infinity to infinity, right? Apul, just
Correct.
1 second, please. So it will be minus infinity to plus infinity, right?
Correct.
Right.
In this
Although the
case.
function is discontinuous, in both the cases, it will be minus infinity to plus infinity.
Yes. Okay, now to the same question I'll ask you, like if this is my graph, okay? If this is my graph, Is it 1-to-1?
No, it is not
Right?
1-to-1.
Yes, sir.
Not
1-to-1.
Not
Then
No,
1-to-1.
it's not.
horizontal line test.
1-to-1, sir, in the domain of 2 to infinity.
Right.
Yeah, that is, I'll give you some special case. Like you can, in this domain, you can tell
But
me,
in
like
this
in this
domain, it
domain.
fails the horizontal line test.
Yes. So you cannot find domain in this case. Sorry. Basically, there is no one function in this domain because
Yes, sir.
here, yeah. So that is one thing we have to understand. But when I restrict my domain, you would have seen question as well. Most of the time, what we do is we restrict it. We say like our function is defined from 2 to infinity. Now, forget about this. Is
Yeah.
this my function 1-to-1 now?
Yes.
Yes, sir.
Yes, it is.
Yes. Now it is 1-to-1. Is it increasing type function?
Yes.
It
Yes.
is, yes.
It is
Yes.
increasing function.
So always pay attention to the domain, okay? If it is R, then no, you won't get anything. But when I restrict my domain, then everything comes out. So pay attention to the domain whenever we give the question, okay?
Okay.
So,
Yeah.
so
Mm-hmm.
this detailed
Go
explain thing I would like to point out, which is if the
Okay.
leading term was, or the leading coefficient was negative, then it will not be minus infinity to plus infinity. Then it gets bounded by the, the vertex of the parabola.
Yeah. So for the same example,
Yeah.
let's say if the leading coefficient was negative, as you told, if it is suppose, let's say negative, okay? 1 minute.
So could you see, is there a reason from line number 1 to line number 2 the negative disappeared?
No, it is a
From where?
different.
On the
Please, I
same
couldn't
page at
understand.
the top. Could
No,
you
they
go
are
to the
not
top of the
connected. We took just a different example. That's all.
Yeah,
I
it's
think we
just an
okay,
example.
For illustration purpose.
The second
all
line
right,
didn't come from
fair
first one.
enough. Okay, fair enough. Thank you.
Yeah.
So, sir, you can now take the first one to explain the point that I mentioned. Probably we just
The
explained
first
without
one, is
going
it?
into details.
Sir,
Minus x square.
before moving that, the second part of the graph that you have shown, log, where we were taking the range as x minus 6 and we were getting the asymptote at minus 6.
Okay.
So, sir, the graph of, we have learned that we are not taking anything in the negative for x. So,
No,
yeah,
we are not
so I'll
taking
tell you why.
anything as a negative for the parameter for log. So x minus x plus 6 can not be negative.
Only the domain
So
cannot be
Srinath,
negative. The range
Yes.
can be.
correct. So Srinath,
Yes.
yeah. So who asked me that question, like the negative values of log x? Was it you, Srinath?
I asked.
No.
I asked Apul.
Apul. Okay, Apul. So that's why we found out our domain for that function.
Yes, right.
Yeah. So if you take any values, let's say when you take x equals to 0, which is not in this domain, okay? Not in this domain. When you take x equals to 0, now you try and understand what does this become. It will give you minus 12.
Correct. It will give minus 12, right?
That's why we restricted our domain for this. We told no initially, like this has to be greater than 0. So there are two cases for it to be greater than 0. Either this term or this term is greater than 0. Both of them should be greater than 0. Or both of them has to be lesser than 0. Then only this will be, overall it is going to be greater than 0, right?
Right.
That's why we did it in the beginning. Like this is the, we have to first make sure that the domain is defined, and that is how we get our, this part has to be greater than 0. That's why we find our domain first. Okay.
Okay.
Yeah. Is it fine, Apul? Like any other doubt in this?
No, sir, got it. Okay, fine.
Okay. Okay. Yeah. So anybody, any other? Yeah. So this was something of graded, right? And somebody was asking me from mock questions, right?
Yes, sir. Sir, my doubt is clear now, sir. I just
Okay, it's clear. All right.
Sir, you were going to explain about the other form of the same equation, sir, the same logarithmic equation, which is written on the top.
Okay. So let's take up that now. Okay, now, but who is this person who's asking me?
So this is Neeraj, sir.
Okay, Neeraj, now you will help me out for solving that, okay?
Yeah, sir.
Yeah. So we will do the same thing. So what we do is, like, I'll just give you a summarized thing. First, if the function is given and let's say a log function with a quadratic equation, all we have to do is like first make the equation of the, first plot the quadratic equation so that you'll have an idea, okay, like how does that function look like, okay? And see, examiner will always trick you with the domain. As we have seen it here, like if the domain is not restricted, it's very difficult to find out what are those values, okay? So you have to make sure that things. Now coming on to the stepwise thing. So first what we can do is we can plot the quadratic equation. Then we can find the domain of the log function, log of that composite function. And then we can actually find out where it is forming an asymptote and where not, okay?
Okay.
That will give us, but always we have to keep it in mind, like how does this function, had it been log of 1.5, can you tell me how does this graph would have been then?
It will be
Sorry,
similar
let me
to
know.
okay.
Yeah, exactly. So, and what about this?
It will be coming from it will be decreasing function, like from top.
Okay, can you tell me what will be its asymptote?
Its asymptote will be x equal to 0.
Yeah, at x equals to 0. And where will that log function tend towards? Negative y-axis or positive y-axis?
Positive y-axis, decreasing decreasing function.
So that is something we have to make sure, okay?
Yeah.
Now to the question, what is Neeraj has asked, like had it been like negative coefficient, is it Neeraj?
Yes.
Yeah.
So this is something even given in the solution, but just to take up quickly, and it will be like a revision for the others as well. So this was 12. Let's say this was plus 12, okay? Okay, Neeraj, so can you help me out? What will be the roots for this?
I believe will be minus plus 6 minus 2. X plus 6, x minus 2.
So it is going to be x plus 6 and x minus 2. Yeah.
Yeah, I think so.
Now how will the quadratic equation look like for this?
It will be downward parabola with the roots at minus 6 and plus 2.
So this is something going to be
downward parabola at minus 6 and plus 2.
So minus 6 is somewhere here. Let's say this is minus 6 and plus 2 some. This is not to the mark. 1 minute. This is minus 6 and this is plus 2. Okay. Now what we will be interested is like how does, so this is going to be a downward, so it's roughly going to look something like this, right?
Correct. So we will be interested in the positive side of the curve. So
okay. Okay,
so
let's see now how does this look like. Okay, so now again this is log function, right? And we have to make sure that this is greater than 0.
Correct.
Yeah, so when this will be greater than 0, again two cases, case 1, case 2. When x 6 is greater than 0 and x minus 2 is greater than 0, and another thing is x plus 6 lesser than 0, x minus 2.
Sir, I think it is x minus 6 and x plus 2.
Yes, sir.
Yes, sir. It is x plus
Yeah. Sorry. Okay.
Because the leading coefficient is negative.
Yeah, I think Neeraj would have got confused with positive here. Is it? Is it Neeraj?
Yeah.
But still that would have not given, because this would have been violated that time. All right.
But anyways, the curve will look like same, no? Curve will look exact like it will shift on the x-axis, but it will look.
But it shifts, na.
Yeah, it is shifted.
Yeah, that's what I'm saying. There will be a shift on the x-axis, but it's okay. Yeah. We are trying to understand the concept.
Okay.
See,
let's go ahead.
I didn't calculate exactly. I just I just guessed it.
Okay, no problem, Neeraj. Okay, so this is basically minus x square plus 4x plus 12, right?
Correct.
Now these are my two cases, case 1, case 2. Now what do I get from here? X has to be greater than minus 6 and x has to be again greater than
minus 2. Sorry, plus 2.
Plus 2. And here x, okay, so let's go ahead completely here. So now what do I notice here is, since it says x is greater than minus 6 and x is greater than 2 as well. So what will be my domain for this function? 2 to
infinity.
Exactly. So now that will be my domain for this. Now what about?
Sir, sorry to interrupt.
There is something
Over here, instead of doing this particular thing, why are we not just focusing on the range of this particular quadratic function? The range of this particular function will become the domain of this log function, correct? So if the range is, if we calculate the vertex of this particular quadratic function, we'll come to know the range. And this is what we need to consider for the log function. That the right approach.
Sorry, Apul, could you repeat again? I just missed the track.
Sure.
Yeah.
So
Yeah.
if we consider the range of this quadratic function,
Okay.
the range of quadratic function,
Okay.
okay, which would be from minus infinity to the vertex, right?
Yeah. So vertex is somewhere at 16.
Minus b upon 2a.
Yeah, minus b upon 2a. So that will give us 16. So it is going to be somewhere at
So for the log function, would we not consider 0 to 16 as something in which we will have to work in order to calculate whatever we have to calculate for the log function?
For 0 to 16, is it?
Yes.
Yeah.
Because
yeah, so
that is where we will be working, right?
yeah, exactly. That is something you learn out of the things what I have told. Like, of course, I have told you so many things. If I was to calculate here, what I would have done is I would have never done all this. It's just for the others who haven't understood. So what here is what you could have done is you could have found the minimum value for this, right? Apple.
Yeah. Yes, sir. I'm listening.
So for Apple, as you know, like a log, log x function is tending from minus infinity to from minus. So basically, you know that log function is going something like this, right? It is tending towards minus infinity. So all we are interested is what this value is, right? Isn't it?
Yes.
Yeah.
Yes.
So that you can get it from equation, and that minimum will be at its vertex value, correct? So you can quickly find what is its vertex value. So vertex here is 16. So 16 of that thing will give me what? So that is something we'll have to find out. So that is, you can do it directly. That's not a problem at all. But this is just an explanation part here for the others who didn't understand. That is completely fine. You take the vertex, you get that will be the minimum value for log, and that will be the maximum value for log, and minimum value
Maximum,
is always
right?
Yeah. So that is something you can get it quickly.
Fine, sir. Okay, thank you.
If it is something asked like what is the domain of this log function, then you'll have to play around with this what I'm doing right now. Yes.
Fine, sir. Thank you.
Yeah. Okay. So yeah. So Neeraj, yeah. Neeraj,
Yes,
you're
sir.
here.
Yeah.
So you got this thing as one of our domain, and from here what do we get? X minus 6 and x lesser than plus 2. So here what do we get? Minus 6 to minus infinity to minus 6, right? You got till here?
Yeah.
Okay. So now I got these two parts. Now I'm interested in what will be its asymptote of this function. Okay, for this log function. So clearly at x equals to 6, that means
Vicky sir, I'm sorry, but you're getting a domain 2 to infinity, minus infinity to minus 6. How is the vertex important here? I won't see that.
yeah, I'll tell you why is vertex important here.
Okay,
See,
not now.
basically,
Finish this. After you finish it. After you finish this.
Yeah. So I'll tell you, because what I'm doing is I'm just trying to find out, okay, where this thing goes first. Okay, and then I'll come to this. Is this fine? Or you want to come from here to here? Hello?
Yeah, I'm here.
Yeah, fine. So what I'm trying to say here is vertex is really important here. But what I'm trying to say here is like, this is something I'm telling you in analogy with the previous question, what I have told. Okay. So that is something I'm doing here. So here, if I find the asymptote will be at 2 and asymptote will be at somewhere at 6. Sorry, asymptote will be somewhere at minus 2 and at 6. So this is how this log function will go, right?
Yeah.
Okay. Now we have to understand like, okay, what will be the vertex for this part? Now, say, had this quadratic function, if you see, this is negative of x square. So what is that negative? Negative tells you that it will have the minimum value or the maximum value.
Maximum.
Maximum value.
So the maximum value of this function will be the maximum value of this.
The asymptotes are at 6 and minus 2, right?
Asymptote is at?
Sorry,
6 and
asymptotes are at
yes.
minus 6 and 2. Sorry, minus 6 and 2.
No,
It
no,
is
no.
for
It is at,
positive.
We are taking
over.
for x plus 6, right?
Sorry?
We are taking for x plus 6 and x minus 2, right?
X minus 6 and x plus 2.
No, sir. You're doing it for x minus 2.
You
There
can take
has
the
been
intersection of both of them.
So there is a mistake. There is a mistake when you are taking the case now. You have you took x plus 6.
Oh, okay, okay.
And
Okay.
there is x minus 6.
Okay. Sorry, my fault. So this is going to be plus 6. Okay.
We will do for x plus 6, no, sir. Why the confusion and all? We will continue with x plus 6 only.
Okay. So this will be 6 anyways. Okay, so fine. So that is all fine then. No problem. Asymptote is at it is at 6 and at minus 2, correct?
Yeah.
No problem with the asymptote, right?
No.
Okay. So now if that is fine, now let's take up this part. Now, since we are interested in finding what is the range of this function, right? So the range of this function here, since this is going to give me the maximum value, right? In the previous example, the maximum value was infinity. Correct?
Sir, I did not understand why asymptote is coming at -2.
Why is it coming at -2? When you give here x equals to -2, this will tends to 0. Here, when you give it x equals to -2, this will become 0. So
yes,
you know
okay.
that. Yeah, you got it?
Fine. That's fair. Okay. Yeah, sorry. Okay.
Yeah, it's okay. No problem. So I'll tell you, in the previous example, what was the maximum value of x? Sorry, what was the maximum value of that quadratic function?
Infinity. It was coming on the top. Infinity.
Yeah,
But,
infinity.
yeah, but in this case, the infinity is not the maximum value. The maximum value is at vertex, right?
Correct.
So now we need to find the maximum value of this thing. So maximum value of this quadratic function will be the maximum value of this as well, right? And the minimum value of this log function is anyways going to be minus infinity, right?
Okay, so the log function is here between the two asymptotes, and there it was on the outside of both asymptotes. That's why.
Could you repeat again?
Okay, so okay. There the positive values were to the negative x-axis and the positive x-axis outside the asymptotes, on the left and right of the asymptotes. And because this is a negative function, the curve is between the asymptotes. I understand now, sir. Got it.
Okay.
I got it. Thank you.
Okay. So since now what it is here, minus x square plus 4x plus 12. So this will have a maximum value, right? So now the maximum value of this will be at what point? It will be at vertex. Neeraj?
Yeah. It will be at vertex.
Okay. So vertex will be, you know how to find out, right? Minus b by 2a.
Minus b by 2a, then I will put the value to the quadratic equation. I will get the y.
Yes. So that will something, it will come out to be something like 16, correct?
Yeah, 4 minus 4.
No, it will be at 4.
Minus 4.
Sorry, 2, positive 2.
Yeah. When you give 2, then the value, the y value, when you substitute
Coming to
2
16,
here,
sir.
yeah, so this will become 16.
It's 16
Then what
only.
is log 2 to the
If you
power
put
of
x
this?
equal to 2.
Do you have confusion with finding the maximum value?
No, sir, it will be 16.
So that
How
you got
come,
it as
sir?
16.
Sir, I have a difficulty. How come it will be 16? If
Okay,
you
I'll
put
tell you.
x equal to 2.
Minus 4 plus 8 plus 12.
Yeah.
This part.
Minus 4 plus 8 plus 12.
Yeah. So, yes, the square will be minus. Okay.
Yes.
Right? So now we got it as 16. Now we know that it will be log 16 to the base 2. This I can write it as log 2 to the power of
4.
So this will be nothing but 4. So now this thing will somewhere converge at 4. So this is something 4. So Now we know that this is tending towards minus infinity. So from 4 to minus infinity will be our value. Okay.
So the vertex is at minus b by 2a, right?
Sorry.
How comes 4 to minus infinity?
Okay. So I'll tell you.
Minus
What is the
b by
maximum
2a.
value of this function? The maximum value of this
16.
function.
So
So
it will
maximum
be
value of function will be maximum value of log 2 of that maximum value. The maximum value of this quadratic function is 16. So
Which
now
is
we
at
are finding.
vertex.
Now we are finding what will be the maximum value of this quadratic function in terms of log. So log 2 of the maximum value, which is 16, is nothing but 4.
That I got, sir. It will be 4.
So that is the maximum value of log. You got it?
Yeah, that I got. It will be the 4 will be the maximum value.
Then what is the doubt?
That you find the minus infinity to 4. That will be the domain.
No, that will be the range.
Domain
Okay,
is something on the x-axis.
Okay.
Okay.
Yeah.
So yeah, this is fine then. So any other doubt? I can take up one more question and then I'll wind up the session.
Sir, I have doubt in mock test quiz 3 first question.
Mock
How do
test
we
quiz
solve
3 first question. Okay. I'll
roughly
take up
5
that
minutes?
question.
So my hand has been up for a while. It was to find inverse. There are definitely going to be
How to
questions
find
for
inverse?
inverse.
Actually, sir, I guess in this question also we have to find inverse because everything comes in the base 3 and then we have to solve by taking inverse, but I'm unable to do that.
Okay. I'll take that. So here what we can do is like it's given to us log 3 5 minus x plus 4 log 9. Then you have root over of 3 minus x is equals to 0 and is equals to 1 and x is lesser than 3. This is something given to us, right?
Right.
So did you see the mock solution?
No, sir.
The PPT which was shared to you? No, is it?
No.
So you can just simply see that you will get the answers. But anyhow, I'll just give you the clue. This can be written as log 3 square root
See,
over of.
mock solution is not yet there in the website, it seems.
Yeah.
Okay, so mock solution is
Not
not
been
given,
given.
but I think PPT is given, is it?
No.
No.
I know. Somebody would email or I don't know, but it's not there in the portal.
No solution
Okay.
is not given.
No, there is nothing.
Okay,
Not
fine.
even
Fine.
PPT is there.
Okay. Okay, fine. I'll make sure like you will have it then. Okay. So if this is the question, so what we can write, we can write like this. Who was Punit? Punit is the one who asked me, right?
Shreyas.
Yeah, Shreyas.
Yes, so we can definitely bring everyone in the base 3.
Okay. Now you remember this formula, which is something discussed even in the graded or like practice solution, a derived formula. So here it is like a to the power of n b is equal, this can be written as 1 by n log b to the base a.
Okay,
Can we
so
write like this? This is something derived in the practice or graded solution of week 9. No, practice solution of week 9. In the first questions, this is something even derived there. Okay, so you can just quickly have a look there. So this is formula which you can take up. This is really handy. Like log of a to the power of n, log of b to the base a to the power of n can be written as 1 by n log of b to the base a. Okay.
yes.
Okay. So now you can see the solution, like video solution, you will have it, or like it's given there. Like I've even derived it there. So you can have a look over there. So now I can take this log 3
So
5
now
minus
we
x.
can take the anti-log, right? So
Why anti-log?
it will be 4 by 2. 4 by 2.
So now what you can do is this will become 2. And when you take this here, so this will become root and a square. So this thing will go off, right?
The root will go off.
Yeah. So then you'll have this thing coming in. So log 3 minus x is equals to 1.
So
Clear?
log 3 into 5 minus x into 3 minus x.
Yeah. So this you can write as 5 minus x and 3 minus x is equals to 1. Now this thing can be further written as 5 minus x, 3
And the 3
minus
minus
x is equals
equal
to
to
3 to the power of 1. Correct?
no.
Is it fine?
Yes. Yes, sir. Yes, sir. Got that.
Oh, why would it be like that?
We have another formula here.
No, sir.
So, Srinath, I think you should go to, I mean, you should just quickly see the formula of these log functions. Okay. So this is very
Okay.
essential. So if I have something like this, okay. So then how do you write this? Then the other formula says x is equals to a to the power of b. Like very basic logarithmic formula. From there I have opened. Okay. So now this part becomes, now from after here you can do it.
Sir, just a question.
Yes, sir.
The log 3, log to the base 3 of 5 minus x into 3 minus x equal to 1 says what should be the exponent of 3 to get 1? Is it correct, sir?
What should be the exponent of
Of
3?
3 to get 1. That is how I. So it should be 0. 3 raised to 0 is 1. So 5 minus x into 3 minus x equal to 0, right?
No.
Exponent of
So
exponent of 3 to get 0 is not 1. It's exponent of 3 to get x.
No, 3 raised to the power of 0 is 1, correct?
No.
No,
One is the
it
exponential.
It is
One is the
e to the power something
log
will give you.
So
log function gives you the exponent.
correct. So 3 raised to the power of
Right.
0 is 1. So that is what this
No,
log 3 into.
exponent here is 1.
You're changing
No,
it. E to
exponent
the
here
power 1
is
is
0.
equal to 3.
1.
okay, Srinath.
Yes.
Okay, now we will take up this here. At what value of this, when this becomes 3, then you will have 1. Log of 3 to the base 3 is 1.
Yeah, correct.
That is what we got it here.
Okay.
Right?
Okay.
Makes sense. So
Correct.
that part you can keep it, but always remember this formula. This is really handy because you will land up in confusions later. Like how should I go and equating? Like always keep this in your mind. Whenever you have it, this is a formula, like standard formula of logarithm. Log x to the base a is equals to b. In other words, it's just a definition. When you bring it in the exponential form, this becomes a to the power of b. X becomes a to the power of b. Okay.
Sir, assume 5 minus x into 3 minus x is 0.
5 minus.
No, sorry. 3 is 0. Sorry, 3 raised to the power of 0, I will get 1, right?
Yeah.
No. How can log of something can be 0?
How is, yeah, log of something. Log of 1 is 0, okay? Srinath?
Oh, okay. I was thinking the opposite.
Hey, sir, I can make a comment, right?
Sir, I have a question.
Yeah.
Yes, Srinath.
Can I
We are taking exponents in both sides. That's it.
Okay. Done.
We are taking exponents in both sides. We are taking exponent of 3, right? 3 into that entire part in the left side and the exponent of the right side. So we are taking the exponent of 3 for both the sides. We are getting the value.
Okay.
Yeah, exactly. So that way also you can do it. So it's like exponents of, so this will be 3 to the power of this and 3 to the power of 1. So these have the same base. So this will become again like 5 minus x and 3 minus x is equals to 3 to the power of 1 or just 3. Okay, Srinath?
Yes.
Yeah. So all right. So I'll wind up the session. It's already time's up. Like if you have further doubt, you can put it in the discussion forum. We'll take that question. Okay.
Sir, I have a question from week 9, graded assignment.
Yeah, so actually, like we have another sessions coming
Thank
up,
you,
so
sir.
that's why we have to end the session now. Okay, and like if you have further more question, you can put it in the discussion forum. We'll take there definitely.
Sir, it's only a small question, sir.
Okay, please tell me what is it?
Sir, how to draw the graph of log x plus 1 upon log x?
Log x upon?
Plus 1 upon log x.
Log x plus?
1 upon log x.
1 minute. So you have log x plus 1, is it?
Plus 1 upon log x.
Upon log x, is it? This
So
is the
not
thing,
whole
right?
upon. Yes,
1
sir.
by
We got
x.
it. Yes.
Is it?
Yes. Yes. Yes.
Okay. So can you? So what is the problem here? Can you tell me, like, how will you what will be your approach for this?
Sir, firstly, we will check
Firstly, you should
for
be interested in
asymptote.
what will be its, the domain for this, and this is definitely going to take time for me to explain this. So I'll just quickly tell you how you have to give an approach for this. Make sure
Yes.
what you are finding, it's always keep in your mind that log function, it's going to be like this, right? And what about 1 by log x function?
Sir, it will be like when the base is between 0 to 1, but
Yes.
that will not cross the x-axis.
Yeah.
The nature will be same.
Yeah. So that how it's good. And then you play around with the domain of x, and make sure that this is also not violated. Like log x is greater than 0 and x also has to be greater than 0. Now play around with this, you will get the graph. Like at least the rough graph you will get it. Okay.
Yes. Sir.
Yeah. Okay. So fine. I'll stop here. If you have further doubt, you can put it in the discussion forum. We'll take up this. Okay. Thank you, everyone.
Thank you so much. Yeah, thank you so much.
Yeah.